we need to understand the force that stops objects from falling through the floor or table. Today, we define the normal force and show how its unique direction is always determined by the surface. First, we examine a block on a flat surface, then we tackle the case of a block on a slope. The normal force is defined as a contact force that arises when two surfaces touch. This force always acts to prevent the object from penetrating or crushing the surface it rests upon. Crucially, the normal force is always perpendicular, or at a 90-degree angle, to the surface itself. Let us consider a block resting on a flat, horizontal table for our first example. Gravity pulls the block straight down, but the table pushes back straight up on the block. Since the flat table surface is horizontal, the normal force points vertically upward, perpendicular to the table. Building on that, let us see what happens when the block is placed on an inclined plane or a slope. The slope changes the angle of the contact surface, meaning the normal force must also change direction. Remember that the normal force must always stay perpendicular to the new, tilted surface. The normal force vector will now point outward from the slope, at a 90-degree angle to that tilt. Imagine a conceptual question asking which way the normal force points on a 30-degree slope. The answer is that it points 90 degrees away from the slope surface, not straight up toward the ceiling. This means the normal force is now tilted and does not point in the exact opposite direction of gravity. You can check your work by always drawing the line exactly perpendicular to the contact point of the object. In summary, the normal force is a necessary contact force that is defined by its perpendicular direction. This perpendicular push allows objects to stay balanced on surfaces, whether the surface is flat or tilted. Keep practicing how to draw these vectors to master force analysis on complex slopes. Generate your own educational videos for free at eduvids.vercel.app.